Hi, welcome back. This time we're going to factor a few different factoring strategies. Look at number 4, and I see that it has 4 terms. The first thing I want to check for is to see if they have a greatest common factor. I look at 5 and it's prime, and none of the others, well, 15 is a multiple of 5, but 6 isn't and 18 isn't, so they don't have that number in common. They also, 3 of them have V's, but the fourth one doesn't. So there's no greatest common factor. I have 4 terms, and that sort of points us to factoring by grouping, or we can use the box, which is another way of factoring by grouping. So let's use the factoring by grouping method here. We're going to 5v cubed plus 6v squared, and we're going to put that in parentheses, plus 15v plus 18. Now, on this, you want to be careful. Like if this third term were negative, this one's positive, but if it were negative, you want to make sure that you put that negative inside the parentheses and then put a plus sign outside in between the two sets of parentheses. Otherwise, you're going to get that wrong. Okay, so here we're looking for greatest common factor for each of the sets of parentheses. So on this first one, I see that they both have 2 v's in common. So v squared. And then I say, well, what would I multiply by v squared to get 5v cubed? And that would be a 5v, because v times v squared is v cubed, plus 6. And I've already taken out both of the v squareds with this v squared, so it's just plus 6. Then I look at the second group, 15v plus 18, and I see that they've got a 3 in common. So that would be plus 3 times 5v and 6. So that's plus 6. And I notice that I've got the same factor here. So now that is the greatest common factor between these two parts, this part and this part. And so I'm going to factor out 5v plus 6. And in that first one, what's left is the v squared. And in the second one, what's left is the 3. So I got plus 3. And this is the factored form of the polynomial that was given. All right, let's look at number 5. Again, we always want to check for GCF first. I look at this and I see they're all even. And this one has a 2 in it, so I can factor out a 2. And I'm left with r squared plus 7r plus 10. And then I'm going to consider what's inside the parentheses because it's a trinomial, see if I can factor it out further. And I remember that I have an imaginary 1 in front of that r squared. And so my AC value for this is what we do when we're factoring trinomials. We take AC, which is 1 times 10, and that would be 10. And our B value, which is the middle term, is 7. And we're looking for numbers that multiply to AC and that add to B. And so I'm just going to go through and list them out. 1 times 10 is 10. 1 plus 10 is 11. Not it. 2 times 5 is 10, and 2 plus 5 is 7. And that's what we're looking for. So then I can rewrite this. I'm going to put the 2 outside the parentheses. I can rewrite this as r squared plus 2r plus, getting ahead of myself a little bit here. R squared plus 2r plus 5r plus 10. And this 2r plus 5r is this 7r. We just rewrote it using the 2 and the 5 that we found. And so it's totally equal to what it was before. It's just rewritten, and now it has 4 terms. So now we can factor it like we did in number 4. When we had 4 terms, we factored it by grouping. And here we can either factor it by grouping or by using the box. This time, let's use the box. And I'm going to come back and remember I've got that 2 out in front, so you need to remember to include that in your final factoring answer. So I'm going to write this then as r squared plus 2r plus 5r plus 10. And then what we do is we factor the greatest common factor for each row and each column. So r squared plus 2r, they have an r in common. 5r and 10 have a 5 in common. For r squared and 5r, they have also an r in common. And then for 2r and 10, they have a 2 in common. And so before we move forward, I'd like to sort of double check to make sure that they multiply out. Let's change colors. Let's go back to yellow here. R times r is r squared. R times 5 is 5r. R times 2 is 2r. And 2 times 5 is 10. And so it works out. Those two factors multiply together to give what we're looking for. So then we're going to put the 2, this 2 right here, we're going to put out on the outside. So that's 2 times r plus 2 times r plus 5. And that would be our final factored form. All right, let's look at number 6. Now, k squared minus 9, this is what's known as a difference of squares. And so the easiest way to factor difference of squares is to think of it as I've got something squared minus something else squared. And if I can write it like that, then it is a difference of squares. So I can put a k in the first box because obviously k times k is k squared. And in the second little box or set of parentheses, I can put a 3 because 3 times 3 is 9. And so then I just go straight to my parentheses here and say, okay, this is k and 3, k and 3, and then I put a plus or a minus. These are called conjugate pairs. And so in the factored form, you have conjugate pairs where the numbers and the variables and everything there are the same except for the plus and the minus that separates them. And in its non-factored form, you have what's called a difference of squares. So this is difference. I'll abbreviate difference of squares. And these are called conjugate pairs. And this is our final factored form. Okay, number 7, I've got 10x squared plus 51x plus 27. Let's see, 10 is 2 and 5, and neither 51 is even for the 2, or 27 even for the 2. Neither of those are even, so 2 won't go into them. And then 5 won't go into 51 or 27 either, and so they don't all have x's. But we checked for GCF. So then we go to our toolbox. We say AC, A times C, that's 10 times 27, or 270, and B is 51. So we're going to look for two numbers that multiply to 270 that add to 51. And we just go to work here, listing out 1 times 270 adds to 270. 271, no. 2 times 135, and that's 137, no. 3 will go into 270, so I just look real quick on my calculator. 270 divided by 3, and it goes in 90 times. And 3 plus 90 is 93. Still no, we are getting closer. 4 won't go into 270. If you try it in your calculator, you get a decimal. But 5 will, and 5 goes into 270. 54 times. And 5 plus 54 is 59. We're getting close, but that's not 51. So then I try 6, and 270 divided by 6 is 45. And 6 plus 45 is 51. So those are the numbers then that we're looking for, 6 and 45. So again, we have a choice here. We can rewrite this and factor it by grouping, or we can use the box. I'm going to go to grouping again. So I'm going to rewrite my 10x squared plus 6x plus 45x plus 27. Remembering that this 51x was just rewritten using my 6x plus 45x. And so it's the same trinomial as we had before, it's just separated out. And that allows us to factor it by grouping. So we're going to go here to 10x squared plus 6x plus 45x plus 27. And then we ask ourselves, what's the greatest common factor between 10x squared and 6x? And I say 2x times 5x plus 3. And over here on the other side, I'm going to say between 45x and 27, I think 9 will go into both 45 and 27. So I'm going to say 9 times 5 is 45. So 5x is 45x. 9 times 5x would be 45x. And then 9 times 3 would be 27. And once again, I see they have this common factor, 5x plus 3 and 5x plus 3. So I'm going to factor that out, 5x plus 3. And I'm going to be left with 2x plus 9. And that would be the final factored form. All right, we'll see you in the next video.